I wanted to make one more video for you all on 1.3 converting measurements to give you a few more examples using the decimal point rule and dimensional analysis. So this is tacked on to parts 1 and 2. This is the 1.3 converting measurements extra practice video. And you do have a learning goal for this. It is get more practice using the decimal point rule and dimensional analysis. Hopefully after this and more work in class, examples, problems, and activities that we're going to do, you'll all feel more comfortable using these two systems. So make sure you take this down. Pause if you need to. I'm going to erase it right away. So we're going to start off looking at the decimal point rule. And we'll do two of those examples. I feel like you've all gotten those pretty much in your head. You know how to do them. It's pretty straightforward. That's why I love the metric system. That's why we use the metric system. So just a couple examples. Here's our first one. Say you've got, here's our example, 54 grams. How many kilograms is that? Remember, we're going to use our King Henry method. So write out the prefixes based on the first letter of that mnemonic. King, Henry, died, deca with DA, drinking, chocolate, milk. Remember, this signifies that we do not have a prefix, so that would be liter, meter, gram, anything like that, without the kilo, the deci, and whatnot. All right, so we are going from gram to kilogram. Gram is here because there's no prefix. Kilogram is here. We are taking 1, 2, 3 steps left. So there's our decimal right at the end of that whole number. It is 1, 2, 3 steps left. You add a 0 in any of those blank spots, and the answer becomes 0.054 kilograms. Let's do another example. If I have 1,200 millimeters, meters, how many millimeters do I have? Okay? Take a moment. Pause these before I do them. Any of them. Try them yourself. See if you can get it, and then check and see if you got it right. 1,200 millimeters. 1,200 meters. Meters is right here because there's no prefix. We're going to millimeters. Right here. That's 1, 2, 3 steps right. So our decimal is at the end of this whole number. We're going to take it 1, 2, 3. So that's going to be an extra 1, 2, 3 zeros in there. So that becomes 1,200,000 millimeters. And that's our answer. So again, decimal point rule, we're just sliding that decimal back and forth depending on the prefix. Pretty good, pretty straightforward. Let's break into the dimensional analysis. A little bit harder. All right. If I have 3 miles, how many feet is that? Well, remember, for dimensional analysis, in order to do it, you need a conversion factor. And I will always give you those, with the exception of a couple, but I'm going to make sure that you guys get used to using them and get used to remembering them before I just throw you into it without that conversion factor. This one, what our conversion factor is going to be is for every 1 mile, there's 5,280 feet. So how we do this, we write out what we have. 3 miles. MI is miles. That's how I'm going to abbreviate it. You'll see me do it a lot. And what I'm going to do is say times and add a line. This is going to be our conversion factor right here. We are trying to get rid of miles, so we're going to put miles on the bottom, and we're turning into feet, so feet goes up on the top. There is 5,280 feet for every 1 mile. So remember what we discussed in class. This, when you've got this number, it's like it's over 1. And when you're multiplying two fractions together, this is literally the same as just extending that together, multiplying the tops together, and multiplying the bottoms together. And if you have two things on the top, or something on the top that's the same on the bottom, you're allowed to cancel it. So look, there's a mile up here and a mile down here. Those go away. Now what are we left with? Well, let's see. 3 times 5,280. You can do that in your calculator. That's going to be 15,840. The feet carry over. 1 times 1 is just this divided by 1. There's no units, so we can honestly just ignore that, and that's our answer. I'll leave it in there because I'm going to write the answer up here. 1,000 or 15,840. That's our answer. It's more difficult than the decimal point rule, but enough practice and dimensional analysis will make more and more sense as you use it. Another example. If I have 24 quarts, how many gallons do I have? Again, start off by writing down here what you have. I'm going to abbreviate quarts with QT. You're going to then need your conversion factor, so you're going to multiply it by a conversion factor, which what you're trying to get rid of will be on the bottom, just like this. And what you want will be on the top. So our conversion factor, again, I'll always give them to you, at least at the start. There are 4 quarts for every 1 gallon. Okay, so again, remember this is just like extending that line. There's a 1 down here, so it's really 24 times 1, 1 times 4. So let's do that. Do we have something on the top that's the same on the bottom? Yeah, quart, quart. Gone. We're left with gallons. That's what we want right there. So this equals to 24 times 1 is 24. The gallons carry over. 1 times 4 is 4. Let's make sure you guys can see that equal sign there. A little bit of glare. Sorry about that. And then 24 divided by 4 will give us our answer. 24 divided by 4 is going to be 6 gallons. We'll write that right up here. There's our next example of that. All right, I'm going to do two more, a little more complicated dimensional analysis problems. All right, my height is 70 inches, so Mr. G, my height is 70 inches, but I am a science teacher, so I want to know what that is in meters, because metric system, yeah. How many meters tall am I? All right, well, let's see. There's no really quick, easy conversion of inches to meters. You could look it up, but it's a little more difficult. So I'm going to go with 2 steps here. And there's actually 2 ways of doing this. I'm going to show you both. I'm going to start with the first one that uses both dimensional analysis and the decimal point rule at the same time. And the other one is just going to use straight dimensional analysis through. So 70 inches is in times. What's the conversion factor? This is one of them that I want you to remember. This is one good one to know. And I will expect you after a few weeks to definitely know this conversion factor. Inches, we want them down here, so they'll cancel. We're going to turn it into centimeters first. 2.54 centimeters per every 1 inch. All right, let's do it. Again, there's that imaginary line with the 1. There's a times here, there's a times here. Inches top and bottom, gone like that. You are left with 70 times 2.54. That's going to be 177.8 centimeters carry over, cm. 1 times 1 is 1, no units, we'll ignore it. So we have it in centimeters. Now to turn it into meters, centimeters to meters, it's pretty straightforward. You use the King-Henry rule, or the decimal point rule as it's really called. We call it the King-Henry rule. So it's King, Henry, died, drinking chocolate milk. We have centi, we need to go 1, 2, over to meters, 1, 2. Decimal goes there. Our answer becomes 1.778 meters. And that's how tall I am in using the metric system. Now for some of you, we're going to go over how many decimals or how many place values is actually appropriate to use. Others, we're going to not go through that. But for some of you, we will talk about, there were 2 numbers here, how many should be here? We'll get into that. Now, I did say there was another way to do this, so let's do that other way. This way broke it into 2 steps. First, you had to do dimensional analysis, then you had to do the decimal point rule, or King-Henry rule. This way is going to use the dimensional analysis technique straight through. So, "70 inches. What's our conversion factor? Times. There's 2.54 centimeters per 1 inch. That's going to stay. We're going to add an extra conversion factor after that, because what this one does is it gets rid of our inches. We want one that'll get rid of the centimeters at the exact same time. So let's add an extra one. There are 100 centimeters per every 1 meter. Now look at what this does. We can draw one nice big line interconnecting all these. So it's times, times, 1, times, times. One big top section, one big bottom. You're allowed to do that mathematically. That's why math is awesome. So what do we have that's the same? We have inches top and bottom, gone, gone. We have centimeters top and bottom, gone, gone. We're left with meters, which is what we want. So 70 times 2.54 times 1. That's going to equal 70 times 2.54 is 177.8 times 1 is the same, 177.8. And that meters carries over, divided by 1 times 1 is 1, times 100 is 100. There's no units. So now we just have to divide 177.8 by 100. And you'll find that it is just 1.778 meters. So both methods work. In this method, you don't have to do 2 steps. You can just do it in a straight chain. It's called a conversion chain. Bang, 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 just like that. And the other way, you do have to do 2 steps. But some people might find one way easier. Some people might find the other way easier. Your call, whichever one you want to use. All right, one last example using that conversion chain so everyone gets an idea of how to use it. If I have 1 gallon How many cups do I have? Well, let's do a conversion chain. I'll tell you that for sure you know there are 4 quarts in a gallon and there are 4 cups in a quart. So let's make a conversion chain. 1 gallon times, for every 4 quarts, you have 1 gallon. So remember, we're multiplying by the conversion factor. What we want to get rid of on the bottom, what we want to keep is on the top, but I don't want to keep that, so let's multiply that by another conversion factor. There's 4 cups per 1 quart. Okay? We're going to make a nice big connection here. There's a times here, times here, times. Don't forget about that imaginary 1 right there. Gallons top and bottom, gone, gone. Quarts top and bottom, both gone. We are left with cups, which is what we want. So it becomes 1 times 4 times 4. That's 1 times 4 is 4. 4 times 4 is 16. The cups carry over. 1 times 1 is 1. Times 1 is 1. There's no units. So this is just over 1. So our answer is just 16. And that is another way to do a conversion chain. So those are a few more examples using the decimal point rule and dimensional analysis. Like I said, we're going to keep practicing these in class. If you are confused and you need extra help, ask me. I am here for you guys. I want you to come and understand these as much. I want you to get these. I want you to understand them. So come see me after class. Talk to me during class. Come see me after school. Come see me before school. Just ask me for help if you need it. See you all in class.